Hi everyone, today we are going to be talking about solving quadratic equations. Go ahead and grab a piece of paper and let's get started. All of the examples that we will be looking at today are already in factored form. So what we are going to do is we're going to set each factor equal to 0 and solve for x. And that will give us the zeros, also known as the roots, and also known as the x-intercepts. And then we're going to go to the Desmos website and plug those zeros in, and we're going to sketch a graph. Okay, here's our first question. 0 equals x subtract 4 times x plus 2. So if I set each of those brackets equal to 0, we get x equals 4 and x equals negative 2. And remember, we can always rewrite those as coordinates 4, 0 and negative 2, 0. So I can go ahead and plot the zeros right on the graph already. So I can put a dot at negative 2 and another dot at 4. And if we just head over to Desmos real quick, we'll just plug it in and then we'll make a quick sketch. Okay, so plugging it into Desmos, I'm just going to take a quick look for my vertex. So 1, negative 9, and 0, negative 8. So go ahead and put those points on your grid and then make yourself a sketch. Okay, once you have yourself a sketch, go ahead and make sure you extend your parabola all the way to the edge of your grid paper and label your line, or your parabola rather. Okay, let's look at our next example. This time we have 0 equals x times x subtract 5. So same as before, we're going to start by setting each of those factors equal to 0. So if we set x equal to 0, we just get 0. And so that gives us the origin at 0, 0. Then we set x subtract 5 equal to 0, which gives us x equals 5, or in other words, the coordinate 5, 0. So again, we can go ahead and plot our points. So I have the origin and 5, 0. And then if we just quickly go over to Desmos, and we will plug in this equation. Okay, so just quickly looking at the vertex, we have 2.5, negative 6.25. So I'm just going to go ahead and approximately put that point on my other graph and then make a parabola. Okay, again, extend all the way to the edge of your grid paper and label your line. Okay, next question. So this time we have just one factor. Because it's squared, we don't actually have to write it out twice. So we have x plus 3 equals 0. So then x is equal to negative 3, which gives us the coordinate negative 3, 0. So I'm going to put a dot at negative 3, 0. And I'm just going to head over to Desmos quickly. Okay, so looking at our graph on Desmos, we can plot the vertex at negative 3, 0, which is the point that I've already drawn on our other grid. And also the y-intercept is at 0, 9. So let's go ahead and make our sketch. And I can plot on a reflective point at 6, 9. And then finally labeling the line y equals x plus 3 squared. This time you'll notice that there is a coefficient in front of the x term in the bracket. So we're going to approach it the same way, setting each of those brackets equal to 0 and then solving for x. This time we're going to be getting fractions. So again, setting our 2x plus 1 equal to 0, we subtract 1 from both sides to get -1 equals 2x, and then we're going to divide by 2 on both sides. So x is equal to -1/2, or in other words, the coordinate -1/2 comma 0. In the second factor, we're going to set 3x subtract 2 equal to 0. So adding 2 to both sides, we get 3x is equal to 2, and then again we're going to divide by 3, so x is equal to 2/3, or in other words the coordinate 2/3 comma 0. So I can go ahead and put those points on the grid, so at -1/2 and 0, and 2/3, 0, and then we can just head over to Desmos quickly and make a sketch. Okay, so the other point that I can add is 0, -2, which is the vertex. So I'm going to go back over to my other sketch, add in the vertex, and then make my parabola. Okay, so making our parabola extend all the way to the edge of the grid paper and then labeling makes for good communication. Okay, let's try the next example. This time we have x times 5x minus 2, so I'm going to set each of those brackets equal to 0. So x is equal to 0, so that's just the origin again, so 0 comma 0. So whenever you see just a plain x in front of the brackets, we know we're going to have an origin of 0 as one of the coordinates. The next factor, so 5x subtract 2 equals 0, so 5x equals 2. Dividing both sides by 5, x equals 2/5, so that gives us the coordinate 2/5 comma 0. So I'm going to plot the origin and then 2/5 comma 0. Let's go over to Desmos so we can make our sketch. Okay, so looking at the sketch onto Desmos, we can see that we have a cluster of points right near the origin. So we have the 0, 0, 0.2 comma -0.2 is the vertex, and then the 0.40 is the other x-intercept that we've already plotted. So we're just going to go ahead and make a little sketch here. Okay, let's take a look at another example. Okay, our last example is 0 equals 2x plus 7 squared. So I'm going to set 2x plus 7 equal to 0. So 2x equals -7. Dividing both sides by 2, x is equal to -7/2. So in other words, the coordinate -7/2 comma 0. Okay, let's head over to Desmos. Okay, so for this graph, we have -3.5 comma 0 is the vertex, and the y-intercept is nowhere in sight. It's way, way up. So I'm just going to make a sketch as best I can on the grid that I have. Okay, there's our last example. So again, make sure you extend your parabola all the way to the edge of the grid, label your parabola, and that's it. Thank you very much for your attention. Have a great day. Bye-bye.